All right, we're going to go over the answers on this handout. Have they seen both sides of the handout? All right, the first question is, while driving down the road, a firefly strikes the windshield of a bus and makes a quite obvious mess in front of the face of the driver. Must have been a huge firefly. This is a clear case of Newton's third law of motion. The firefly hit the bus, and the bus hit the firefly. Which of the two forces is greater? The force on the firefly or the force on the bus? Zach, what's the answer?
It's okay, Zach.
Is it that they're equal?
They are equal.
Yes.
All right.
That's right.
Right.
Oh, no.
That's the whole point of
It
of
wasn't a
this.
question.
The
Common
force
sense.
is equal and opposite.
It's not.
However, we have quite a bit more acceleration due to the bus, right?
That's what I was- yeah.
So the firefly is going to feel more of the damage than the bus is going to feel.
A little bit smaller.
So,
Just a little bit.
you're right. So, but when it's talking about forces, equal and opposite. So watch the wording. All right, number 2. For years, space travel was believed to be possible because there was nothing that rockets could push off of in space. Oh, I gave this one away. To provide the propulsion necessary to accelerate. This inability of a rocket to provide propulsion is because, all right, and the answer is nonsense. Rockets do accelerate in space. It has nothing to do with pushing off of the atmosphere. It's action, reaction. All right,
If anything, atmosphere pull it back.
what's that? The atmosphere actually works against it.
Yeah.
Yeah. All right, but they were like, we'll talk about a blast off in a second to kind of clarify it. But they were thinking like when a rocket is sitting on the ground, that the explosion pushed off of the Earth. So they wouldn't have any of that push off if it was in space. But that's not what was happening. All right, last one. Many people are, not last, number 3. Many people are familiar with the fact that a rifle recoils when fired. Anyone ever feel recoil?
Yeah. Very interesting. She was
Alright.
shocked and it's like boom and it's like
Ouch. This recoil is the result of an action-reaction force pair. A gunpowder explosion creates hot gases that expand outward, allowing the rocket to push forward on the bullet. Consistent with Newton's third law of motion, the bullet pushes backward on the rifle. The acceleration of the recoiling rifle is, all right, the acceleration this time. You see what the wording is? So I said be careful. Before we asked about the force. Now we're asking about the acceleration. So hopefully when you're shooting a gun, the acceleration of the bullet is going to be a little higher than the acceleration of the recoil, or your shoulder is trashed, all right? So the acceleration of the recoiling rifle is smaller. The recoiling or the acceleration, it's moving, it's accelerating backwards. It's going to be a lot smaller. So the answer is B, than the acceleration of the bullet. All right, so you got to watch what they're asking. All right, 6 pairs. All right, there's 6 of you. So Zach, you start us off.
Man on seat, seat on man.
Man on what?
Seat, seat on man.
Oh,
Okay.
Tractor.
Okay.
that's fancy.
All right.
Mhm.
All right, I see. I was looking at this man. I said the seat of this man is not on. All right,
Oh,
the
yeah.
guy in the
It's got a seat
tractor.
on the tractor.
All right. All right, Alex.
I said the tire in the floor.
Right.
One. And then I said the
Well, that's one. You're done. What's the opposite one? Tire on the ground.
ground on the
All
tire.
right. Next.
Elephant on the ground, ground on the elephant.
Yeah. Brian.
Invisible 4 feet.
Hands on the wheel.
Right. And
Oh, what the heck is this?
wheels on the hands. All right.
Some of the hands.
Brian. All right, Emily.
Wheels on hands.
The rope on the man and the man on the rope.
Right. Definitely. A little bit of action there. Yeah.
Tractor on the rope and the rope on the tractor.
Okay, right. Gravity, the earth on the man, not the man in the seat, but the gravity on the man and the man on the earth on the man on the earth. So,
I didn't think about that one.
uh-huh.
Wait, would that be that one? Because if he's being pulled out, then
Yeah, there's still
He's
the act of
defying-
gravity. It doesn't stop. Alright,
He's not.
I think you got this down. We'll just finish with the idea of the rocket. So you might have to explain this in the future, so you may take a note if you want. But if you draw a rocket, some sort of missile, there's combustion that takes place, an explosion, and what all these molecules come flying out of the back. Lots and lots, tiny, tiny masses, but enormous accelerations. So F equals ma. So we have a very small mass coming out. All those molecules from the explosion, but extremely large acceleration. Those molecules, even though we can't see them, are accelerating outward from the explosion. Large acceleration. Outward, backwards. So, because of that, there's an equal and opposite. So we have a small number times a huge number. Does that create a pretty big force? It does. So therefore, that creates an equal and opposite reaction this way. So well, it's got to be the same number, same force, so let's do that one in green. Here we have a pretty large mass, so mass is large. It's not like the Earth or anything, but it's a fairly large mass. And these two numbers are going to be equal. So we have a small number times a huge number. So the equal and opposite reaction is a large mass times a large acceleration. So it'd be better if I had numbers. But do you see how small times really, really large is going to equal large times large? And we're going to see an acceleration of that rocket. All from those minuscule little molecules shooting out the back, creating action-reaction pairs. It's quite fascinating. All right, let's put any other questions about this law. Let's put that one to rest then, and we have a few minutes to get done to start our review. And we're going to review all day Monday and have a test. Good, we have good 12 minutes. So before, just some old business. I marked off everybody except Zach. This one for you.
Yeah, I know.
And you had 2 more to do.
Yeah, I finished one of them.
All right. So keep that in mind. Do you need help on that last one, or
Yeah, let's do the second to last one, number 9.
you need help on that one?
Yeah.
All right. Well, when next time we have a moment, I will try to help you on that, and we'll get that checked off. If I forget, please remind me. All right. I guess we'll go ahead and start a bingo review then. We have a few questions. I also have just a written sort of practice test.
Look at that.
We'll bingo today, and we'll do the written practice test on Monday, which is just creating a study sheet. All right. So, guys,
Bingo
in
review.
video land, it's kind of hard to videotape a bingo
Yeah.
game. So, what I'll do is I'll write down the questions and their answers, and I'll show you those on the video. So, see you later.